This video isn't about how to drink water the right way. Instead, it's about why your body doesn't always use the water you drink as efficiently as you'd expect. We'll follow one single water molecule from your tongue to your cells. Along the way, you'll discover why simply drinking more water doesn't always lead to better hydration. Why do some people still struggle to stay hydrated, despite drinking plenty of water? To understand why, we need to look inside our cells. For a long time, even the smartest minds didn't understand how this works. For decades, science believed water simply leaked through cell membranes, crossing them through passive diffusion driven by osmosis. Everything changed in 2003 when Peter Agar received the Nobel Prize for a groundbreaking discovery. He discovered aquaporins. These are microscopic protein water channels embedded in your cells. They're insanely selective. One aquaporin can transport around 3 billion water molecules every second. But these channels don't actively pull water inside, they simply provide a pathway. Water doesn't move just because the gates are open. It moves only when your body maintains the right osmotic conditions. This osmotic gradient is the hidden driving force that determines how water is distributed between your cells and surrounding tissues. So what happens when those conditions become less favorable? It's like a locked club. The water is right outside, yet the cell may still struggle to receive enough of it. So, how do we get trapped in this loop of constant drinking? The answer lies not in our biology, but in a historical misunderstanding that shaped modern culture. Where did the 8 glasses a day myth actually come from? Well, it wasn't until 2002 that Dr. Heinz Valtin decided to track it down. He traced the myth all the way back to a post-war recommendation from 1945. The document stated that adults need 2.5 liters of water per day. But everyone skipped the very next sentence. It read, most of this quantity is contained in prepared foods. Your fruits, vegetables, and even coffee count toward your hydration. What happens when you repeatedly drink large amounts of plain water? Healthy kidneys usually remove the excess with ease. But if you consistently drink more water than your kidneys can excrete, you disrupt your fluid balance. Flooding your system with plain water without replacing vital electrolytes dilutes your blood sodium. In severe cases, this dangerous condition is called hyponatremia. So why can low blood sodium become life-threatening? For millions of years, our ancestors rarely found salt. Therefore, our bodies evolved highly efficient systems to conserve water and sodium. Every cell depends on a tightly regulated balance of water and electrolytes. Even small shifts trigger powerful hormonal responses that protect your circulation and vital organs. Dr. Tim Noakes helped show that, in endurance sports, overhydration can be more dangerous than mild dehydration. Excessive water intake can dilute blood sodium. As blood sodium falls, water follows the osmotic gradient and shifts into cells. Normally, vasopressin levels fall, allowing the kidneys to excrete the excess water. But if these protective mechanisms become overwhelmed, the system breaks down. Your body prioritizes maintaining blood volume and the function of vital organs. As your body works to preserve blood volume and protect your vital organs, you begin to feel fatigued. Even small changes in fluid balance can affect physical and cognitive performance. If pure water fails us, what kind of water actually works? To answer this, we need to separate marketing nonsense from actual science. This has nothing to do with structured water myths. This is real biochemistry. Water in whole plant foods naturally comes packed with electrolytes, carbohydrates, and organic structures. You see, your intestine doesn't simply absorb water, it takes it in alongside nutrients. When sodium and glucose pass through specialized transporters, water naturally follows the osmotic gradient. That's why adding a small pinch of salt or a splash of lemon to your water helps your body absorb and retain water more efficiently. This very principle lies behind oral rehydration therapy used worldwide, supporting a more gradual absorption and better fluid retention. But water doesn't simply slosh around inside your body. It's distributed between your cells, blood, and the interstitial space, including connective tissues such as fascia. Think of fascia as something like a gel sponge. Prolonged inactivity can reduce tissue mobility, making this sponge less effective at moving and holding water. When you sit at a desk for hours, fluid can accumulate in some areas while other tissues receive less of it. That's why simply drinking more water doesn't guarantee better hydration. Movement itself is what helps drive and maintain normal fluid distribution throughout your tissues. So, how do we build a hydration protocol that actually works? First, stop chasing arbitrary gallon goals. Standard one-size-fits-all water intake recommendations ignore individual human physiology. Instead, learn to pay attention to your body's natural signals. But don't overlook chronic stress. Chronic stress keeps your sympathetic nervous system constantly switched on. As a result, the calming activity of your vagus nerve goes quiet. Together, these changes distort your brain's natural thirst regulation. In a stressed state, you might be severely dehydrated and not feel it at all. Second, don't forget electrolytes, especially when fluid turnover is high. If you lose fluid through intense heat, heavy exercise, or illness, pouring plain water into your system can further dilute your blood sodium. In these moments, replacing both water and minerals is vital. Look for well-balanced electrolyte formulations containing sodium, potassium, and magnesium. If you're sweating heavily for a prolonged period, simply adding a small pinch of salt to your water may help replace some of the sodium you've lost. Third, get more of your daily water from whole fruits and vegetables. Don't just rely on liquid from a glass. Eat plenty of fresh fruits and vegetables rich in water and minerals, like cucumbers, berries, oranges, and leafy greens. Inside plant cells, water is stored alongside nutrients and released gradually during digestion. This provides a steadier release of water during digestion, which may support more gradual absorption than rapidly drinking a large glass of plain water. Fourth, stop fearing your morning coffee. The old belief that caffeine ruins your fluid balance has been thoroughly debunked. High-quality research consistently shows that for habitual caffeine consumers, moderate caffeine intake does not cause dehydration. Your morning cup contributes directly to your total daily fluid intake, so you can enjoy it without guilt or the need to compulsively chase it with extra glasses of pure water. Finally, stop celebrating perfectly clear urine. The internet has convinced us that clear means healthy, but persistently clear urine usually means your kidneys are working overtime to flush out the excess water. By drinking more water than you need, you're simply increasing the amount of electrolytes you lose in your urine. For most healthy adults, pale straw or light yellow urine is one of the simplest practical signs of adequate hydration. Hydration is about far more than simply drinking enough water. Real hydration isn't determined by how much you drink. It's determined by how effectively your body absorbs, distributes, and regulates that water. Want to learn more about the science behind this video? Check out the links in the top comment below. Thanks for making it all the way to the end. If you're enjoying this format, hit that like button and subscribe. We're breaking down serious medical topics with simple words and mind-blowing visuals. See you in the next video.